Hi there, my name is Eric, and this is a presentation on photography for birders and other wildlife enthusiasts. This is Chapter 1. This is the original image that I caught using my camera, and this is what I saw in the viewfinder. Typically what I will do is take that image and I will crop it so that I have an image more appropriate for displaying. This is another example. This was the original image I caught. This is the cropped image. So resolving power is the ability to capture detail. More resolving power means more pixels, means more cropping ability. It's kind of like having a more powerful telephoto lens. That doesn't mean that having a more powerful telephoto lens isn't necessary, but there's benefits to it. This is a 100% crop. Each pixel on the screen is represented by a pixel on the camera, so it's kind of a 1-to-1 ratio. You can get a huge amount of enlargement on a monitor. A high-definition screen has a little over 2 million pixels on it. The camera that I shot has 20 million pixels, so there's a 10-time pixel density, which is about a 3.2 times magnification, and that's because there's a square root thing going on. 4K is a different beast altogether because 4K is so much larger. It's a little over 8 million pixels. There's only about 1.5 times magnification. I just want to take a minute and talk about screen resolution versus print resolution. Screen resolution is about 72 dots per inch. So on one square inch of screen, there's 14,000 dots. Print resolution is much more denser than that. You cannot print at 72 dpi and expect to get a good print. It's going to be very muddy. So you need typically 300 dots per inch. You can print lower than that, but it's not recommended. But in a pinch you can. But at 300 dots per inch, that's 90,000 dots. Okay, so you have to have a lot more pixels to make a good print than what it does on a screen. An 8x10, for example, on a screen needs 1.2 million pixels. That's not really that many. But if an 8x10 on a print, you need over 7 million pixels, and that's a different thing altogether. One of the big questions you need to ask yourself when you're out taking pictures is, what do you want to do with your image? Okay, so resolution is important, but it doesn't mean anything if the subject is blurry or poorly shot or is really small and it's just lined up all wrong. So the nature of an image is going to affect its quality. Sharpness is an important thing. Quality of the lens is an issue. ISO settings are an issue. We'll talk about that in another chapter. And shutter speed and vibration mitigation technology are also important. Amount of magnification is a factor. The zoom power of the lens, the crop factor of the camera. We'll talk about that in a bit. And how many pixels there are. Not only the pixel number, but the quality. And what I mean by that has to do with the size of the sensor. Also the generation of the sensor, that's another factor. Nature of the camera has a huge impact on things like number of frames per second, number of frames you can shoot before the buffer fills up, focusing and tracking ability. Even though it's a lens thing, it's also a body thing. And how easy is it for you to actually use this thing? Let's take a minute and talk about sensor size. There are 4 aspects to sensor size. There's how large the sensor is, which includes its physical size and any crop factor. How many pixels there are on a sensor. Basically, we talk about that in megapixels, which relates to resolution. What the proportions are. So is it a square sensor? Is it a 4/3? Is it a usual 35 millimeter type film, 3:2, 5:4, which is common in some of the smaller digicams? What generation of sensor is it? Older ones produce more noise and more moire. So this is an image out of one of my books, and basically it just shows you the different sensor sizes relative to a full frame. Many of you may have the APS-C sensor, and some of you have got the 4/3 systems, and then of course there's the compact sensor. Depending upon how big your sensor is, you're going to have a different signal to noise ratio, and that is going to alter the quality of the image. Having said that, there's been quite a few changes over the years in the quality of the sensor, so you can still do amazing things with small sensors. So what is this crop factor thing I've been talking about? It has to do with the physical size of the sensor compared to 35mm film. Full frame cameras have the same size of sensor as one frame of 35mm film does. Now this is the thing here, is that focal length is based upon how much magnification you're going to have to tie into the millimeter value of the lens to equate it to a full frame camera. So we talk about that number as being a relative focal length. A smaller sensor has a crop factor, and we need to use that to compare it to relative focal length. So if you take a look, for example, let's say that the top photograph was photographed using a 50mm lens on a full frame. And you take that same 50mm lens and you put it on an APS-C size camera. That's the top one to the right. You're going to have a much smaller portion of the image being shown. That's the crop factor. You take that same 50, put it on a 4/3. Now you're making it even smaller and on a compact, that 50mm is acting like a fairly strong telephoto. I'm just going to spend a minute on this. If you want to peruse it, just pause the screen and have a look at it. Basically, this information talks about the various different sensor sizes, how big they are, what the crop factor is, and pros and cons on those particular values. So these are some photographs I've taken using a variety of different lenses. This is just to give you an idea of some of the things you can do depending upon the lens that you have. There is quite a bit you can do with any one camera and any one lens, even if it's not something that may be thought of as being a professional unit. The fact of the matter is over the years I've probably owned 20 or 25 cameras and probably 40 or 50 lenses, and they come and go. And as I'm doing this, what I do is I do the best I can with what I have. Really, that's all you can do. And so one of the things, of course, is the ability to get out and go places. And another thing is the ability to bring equipment with you. And if you have better equipment, yes, you can typically get better photographs, but it's not always the case. One thing people have a question about is what's going on with binoculars, and how does binoculars relate to what it is that I've got on my camera. So binoculars typically have a factor something like 8x40 or 8x40. We have to refer this to a normal lens before we talk about this very much. So our normal lens gives us the same perspective that we have with our eyes. For a full frame camera, that normal lens has a value of about 50mm. A telephoto lens magnifies an image, and the amount of magnification is relative to the focal length. So to determine how much magnification is going on, we take the relative focal length. Now that's an important thought, the relative, not the actual, because if you've got a smaller frame camera, then the relative is actually longer. You have to include the crop factor and divide that by 50. And so that gives us a value. So for example, on this lens here, which is a 300mm, it's going to, if you divide that by 50 in a full frame, that's going to give you a 6 times magnification. On an APS-C sensor, that's going to give you a 9 times magnification. Okay, so features of lenses. What's the best for burning? We're going to talk about two different kinds of lenses. We're going to talk about prime versus zoom. We're going to talk about minimum aperture and this thing called bokeh. What kind of distortion is there? Some of the things to consider there. Internal versus external focusing. And what about vibration reduction? So a prime lens is a lens that cannot zoom. It has a fixed focal length. Okay. Now, some people get this mixed up a little bit. Focal length is not the same as focusability. Yes, you can focus, but you can't zoom. Okay, these are examples of prime lenses. Okay, the 50 millimeter that I've mentioned before. Some of you may own that because they're really great portrait lenses, especially on an APS-C body. And then these are some other values. Prime lenses are popular for a couple of reasons. They're very fast, meaning that they have a low f number. They produce high quality images because they have less glass, and typically they're built well. They're lighter because don't have as much glass in them. Tend to be smaller, especially some of the new stuff coming out. They're making it about 1/3 the length of the old ones. And you can put a teleconverter on it and still get decent apertures. These are two examples of photographs I took with prime lenses. A zoom lens, of course, tends to be a little more popular. Most people are going to own a zoom lens. They have a wide range of focal length. There's two basic categories of zoom lenses. There's your wide angle to telephoto zoom and your telephoto zoom. So a wide angle telephoto is going to be sort of an all-in-one lens that you can do landscape pictures with on the one hand and zoom in on the other hand to shoot wildlife or whatever it is you want to do. Telephoto zooms have no wide angle function. They're basically built with one thing in mind, which is to get close. So again, these are some other photographs that I've taken with zoom lenses. And each of these has been photographed by myself out shooting and enjoying things and just having a good time. Wanted to take a minute and talk about why longer lenses are important. So if you take a look here, I have two photos. The one, if you look top left, that's the photograph I had on a 480 millimeter lens. And the bottom one is about 240 millimeters, so you can see there's a clear difference between how much you have in the lens. To get the same picture on the right, you have to zoom in, not with the camera, of course, because you're already at whatever millimeter you are, but you have to crop. You have to crop significantly. And the quality of the image suffers with the more cropping that there is. So more cropping means less quality. And if you can crop less because you have a more powerful lens, then you're going to end up with a better image. This is just a quick thought about teleconverters. All a teleconverter is a lens system that fits between your lens and your camera. It magnifies the image, but you also lose light. Lots of pros about them. They increase focal length. They work well with prime lenses. Vibration reduction still allows you to work. And you can still get decent shutter speeds out of them. There's good quality ones that are available. They're pricey, but they're good. The downsides, is that you lose quite a bit of light, somewhere between 1 and 3 stops, depending upon which one you're using. Have limited success with zooms, especially with the higher f1, so an f5.6 becoming f11, you're not going to get your focusing to work very well. If there's no vibration reduction, then you're going to have big issues with performance. These are some photographs I've taken using regular lenses and teleconverters. These are shot with prime lenses. This is a 300 with a 1.7 teleconverter. And this is a 70 to 200 f2.8 with a teleconverter. Bokeh is what the background, out of focus background, looks like. And different lenses are going to produce different bokeh. The background is not always the same. There's huge variations in what the background looks like. If you're looking for a lens, you want something preferably with 9 blades on the aperture. It gives a very nice out of focus background. You can see there's what the blades look like. Focus capabilities is another issue, and we will have to continue with this on a second part. So I will do part 2 on this, and you can continue from there. So thanks for taking the time to watch this, and look for the second part.